So today we are going to talk about Spark on Kubernetes, and to deliver this session, we have with us Pradeep Kumar Mishra. Pradeep Kumar Mishra is basically a senior architect with Cognizant, and is also part of AWS Community Builder program. And Pradeep has been working in data space for more than a decade now, building scalable and reliable data pipelines, and with AWS data services in specific for around 5 years now. Now, today he is going to present on Spark and Kubernetes, and is going to tell us why it is required in today's world and how to run Spark on Kubernetes with an hands-on demo. I am very happy to have him presenting here on AI Engineering YouTube channel. I am even more excited because of the topic that he is delivering. The reason is, as we move into large data sets in industry, Spark and Kubernetes and a distributed file system processor like Spark is a key to build scalable and reproducible pipelines with all the dependencies managed within it. So, with no further ado, I am handing it over to Pradeep. Pradeep.
Thanks, Rivasan. Thank you for that introduction, and also for inviting me for this very exciting session. And hi, everyone. Thanks for joining. Today, we will be talking about running Spark workloads on Kubernetes. And for that, we'll be using AWS EKS, which is Elastic Kubernetes Services. It's a managed services from AWS. So as we begin, our agenda for today will be more about talking about the need for running a Spark on Kubernetes. We'll talk about how to do dependency management, how to set up EKS clusters on AWS, and then also running Spark on Kubernetes. We'll see a hands-on demo on that. So as we begin, I think the first thing we need to talk about is what's the need for running Spark on Kubernetes. So the first thing that we see is more around dependency and version management. As we are creating complex, pipelines, data pipelines, and machine learning workflows, there is a need for the use of the latest the versions of different packages. We have always used this single cluster where we have a configuration, a single version installed, and we have tried setting up multiple versions config so that we can use different options. But that's getting more and more complicated as open sources are. We are getting more and more versions, more and more frameworks that are being released. So there is a need to manage these versions and package them properly so that we can take this beyond one environment to another and run that without any issues. So that's one of the challenges that we are seeing. And that is where the Spark and Kubernetes comes in, because and we will talk about more how containerizing it and dockerizing these workflows, we are easily able to manage those dependencies, interdependencies, without impacting anything else that could be running, and then also have most of our needs met too. So that's the first challenge. The second challenge I want to talk about is we have multi-tenancy in our clusters. We have different teams working on the same cluster. And then we talk about how do we manage those multi-tenancy in the cluster, and then how do we efficiently scale those clusters without impacting someone else. Now, we have tried multiple patterns, like there could be a cloud bursting on-prem, but then extend it to the cloud, or even in the cloud, you want to scale even more nodes, and so that all the workloads get the CPU, the memory, and the processing, the infrastructure it needs, right? And then how do we efficiently manage that? So that's another challenge that we see in running the models and the data pipeline workflows. And the third challenge is how do we create an efficient and a very optimized DevOps and an MLOps pipeline, right? And then not worry about where we are shipping that code to, which environment, what's the dependencies on that environment, and not worry about that, but can move our code to a particular environment and run it and then also reproduce that code, right? Not only from the code perspective, but also ship the environment along with it, so that it's all isolated and then easy to reproduce that code without any issues going to different environments. So these are the top three challenges that I have, and we have listed out, but there are many more. So that is where the Spark with Kubernetes comes in, because with Kubernetes, what we are essentially doing is we are trying to Dockerize those jobs that we want to run. So that means not only the application code is bundled, but also the necessity dependencies and also the libraries. So that forms a complete package of the image, and that image can go and run independently on the cluster and any environment without without we worrying about what are the dependencies, what is the configuration set on the clusters, all of that. So with those challenges, today I will be going through a demo of setting those different components. And this is the demo environment that I have for today. So I have most of the client softwares installed on my local machine, which is I am referring to as client. So I have Docker and the Docker services up and running, because I'll be creating and showing you how to create the images in this client. I also have a Docker registry, and I will talk about the need for that. Now, to interact with Kubernetes, whether it is a Kubernetes cluster on my machine, or it's on a cloud, or it's in a different infrastructure, I need kube control to execute and interact with the Kubernetes cluster. So that's the reason why I have got kube control installed. And since I am doing this on AWS, I am using most of the AWS CLIs to interact with to set up some few things, to check, infrastructure and services. That's where I got AWS CLI. And then EKS with the AWS comes with its own utility to manage the EKS clusters, which is called EKS control. And that is something that I have on my local as well. And finally, since we are going to demo on the Spark code, I got the Spark binaries, and I will walk you through how to get that too and create those containers. Now, coming to the other side of it, the Kubernetes cluster is on AWS. And basically, it's a managed services that I'm using. So I don't have to worry about internally setting up the nodes and individual instances. So I am using EKS to create a cluster. And then my container repository is also on AWS, which is ECR. Now, there are various options on AWS and setting up EKS. Like I can have a Fargate instance, which is, for example, serverless. And what happens is with the Fargate, the drivers and the executor, the pods are actually, or the worker nodes are created when the job is submitted. So there is not a persistent workers running. It will be triggered and created when there is a request to execute a job. For today's demo, I am using dedicated nodes, just in the interest of time, because with Fargate, it takes some time to spin up those instances because the nodes get created. But with dedicated instances, we will be able to see the results faster. That's where I'm using the dedicated worker nodes for this demo. Now, with that, let me jump to my console. Quick check. Everyone is able to see my Srivasan, you are able to view my screen?
Yeah. I'm able to see it, but not the console. You're on the terminal.
Yes, on the terminal. So the first thing that we will be doing here is I'll be creating an EKS cluster. Now, to create an EKS cluster, I have created the config already, and have also created the cluster because it takes some time. But I will walk you through this YAML file and some of the configurations and setting that I have specified here. So I'm creating here, what this says is basically, if you look at this highlighted section, what I am asking EKS is to create a EKS cluster with the name of Spark cluster, and the region would be US East 2. That's the Ohio region of AWS. That's what I'm using today for the demo. And the version here is the Kubernetes version. Um, we have to match the Kubernetes version of that is supported by EKS and AWS. So right now, EKS supports 1.15 and beyond, not lower than that. So it's always 1.15 and above. So we will have to constantly look at the version that we want to use of Kubernetes, and if that is supported by AWS. And then since I'm using US East 2, I'm using 3 availability zones, and then I'm creating that's about the metadata of the cluster. Now the worker nodes, I am actually creating 2 worker nodes, and then the type of instances I need, and then I'm calling them Spark nodes. Now, along with that, the final thing I have is I am attaching the IAM policies. So we have to specify the ARNs. So ARNs are the resource names, Amazon resource numbers, and then that gives you that which policy will be tied to this particular cluster. So once this file is ready, what we have to do is we have to use EKS control and then create cluster and give this file as an input, and then that basically spins up the entire cluster, which I have already done. It usually takes around 20 to 25 minutes because it does the networking, it creates the nodes, it creates all the control plane, starts those services, all of that. So for a 2 node cluster of this size, it will take around 15 to 20 minutes for everything to come up and be ready. The second thing I'm doing here is that once I have the cluster up and running, I am creating a policy here, and that's actually I'm creating a service account with the name of Spark. This is what the job will use to create the drivers and executors. So that is then rbac role that I'm creating so that I can use this to create later on. We'll see how we are using this, but this is what is needed for the driver to launch the executors and other worker nodes. So once this is ready, now if I do a describe node, you can see that my cluster is up and running. The various stats, there is nothing else running at this time. So you can see that the requests are pretty low. It's idle, pretty much idle. So this is on the Kubernetes cluster setup. Now, if I go to the quickly to the console, this is the cluster that we just were talking about. So the Spark cluster version 1.15, all the configurations that we saw. And then if you come to the EC2 instances, these are dedicated worker nodes. So there is an EC2 instances that it spins up on the background and makes it available. So these are the 2 EC2 instances that we requested for, and it's up and running. And then once the EKS cluster is set up, because now we have created the EKS cluster, we have created the service role. So basically for running our jobs, that's all we need from the EKS perspective, and it's all set up. Now, the other thing we need to do on AWS over here is we have to create a container repository. And I have already created a repository with Kubernetes time series Spark. And what this repository is used for is this is where we put all the images. And when we do later on run our Spark jobs, the EKS cluster pulls the image from the ECR repository, and then it starts that. So this is the repository where the images will be pulled from, and then this is the repository that I have already created so that we don't have to wait and then watch this getting launched. All right. So far, if a quick recap so far, we have created the EKS cluster. We created a role service role and did the role binding. we created, and we are seeing about ECR, and the ECR repository is already created. Next, next we'll work on creating our Spark jobs. So the first thing that we need to do is we need to download Spark binaries. So for and then it's we have to go to Spark homepage and say downloads, and then it will ask us to select the release and the package, and then you can download the tar file, the zipped tar file. So for this demo, I'm using 2.4.7, and then for Hadoop 2.7. Now we can use, there are other options 3.0, and you can choose various other options as well. But the one that you see on the screen right now is what I have used for this particular demo. So once we download this, we untar it, and once you do that, you will see that all the folders are extracted, and then the binaries, the jars, all of them are in this particular different folders. In this particular context, since I will be I know that I am working with AWS, what I also did is I went to the jars. If you So along with the Spark binaries and libraries that are there, I also added the AWS jars. So these are the specific AWS binaries and jars that are needed for the Spark job to interact with AWS services. Like if you are writing to S3, or if you want to use anything else, these are the binaries that are needed. One word of caution is look for specific versions, both the major and minor versions, because it's compatible. So with Spark 2.7, these are the two versions that are compatible that we can work with. So I included that in the jar as well, along with the other jars.
Pradeep, sorry to interrupt. Can you make it like little bigger? The kind of terminal size.
Sure.
Yeah,
Is it better now?
yeah, it's better. It's far better. Yeah.
Okay. All right. Thanks, Wilson, for letting me know. So, what we have is here, what I was referring to is I have also added the AWS specific jars here, so that our Spark can talk to the AWS services. Now, what we are going to do is uh, we are going to create a base Docker image just with Spark. So we don't have our code yet, none of that. We just downloaded the Spark binary from the download Spark homepage, and then we extracted it. We added the AWS specific jars, the Hadoop AWS and Java SDK jars. And then next, what we are going to do is we are going to create a base image for this Spark. Now, so what happens is with the Spark 2.4 and beyond, the Spark itself comes with an utility to create a Docker images. So it comes with a utility called Docker image tool.sh. Now it helps to build you Docker images using all the libraries. It will package it for us, and rather than creating our own Docker file. So I'm going to use this Docker image tool.sh to create the first base Docker image. This base Docker image only contains all the binaries, all the dependencies that are relevant to Spark. And then later on, we will see using that base image, we will build more derived images and containers, which will have specific application code that we need. So how we do that is once we have until this point. We are here until this point. I will go just back. And then what we call is, in the bin directory, I have docker image tool.sh, and then I call build. There are other options here, like I can tag this build, I can assign it to a different repository. There are various other options if you would like, but for now I'm just creating a base a docker image with Spark libraries. So it will take a few seconds. And what it does is it creates 3 Docker images that we are interested in. It will create a base Spark, it will create a PySpark image, and then it will create a Spark R image. So you will see it created a Spark R at the last, and before that it used a Spark Py, and then the first it just created a Spark image, the Spark image over here. So if you see these 3, these are the base images that are created. Since I created it again and there were no changes in the binaries, it did not modify anything, but it did run the entire thing and checked whether there are any modifications, or else it would have updated it. So these are the 3 base images that are created, and we will use this image for bundling our application code along with it. So once this is done, the next is we need to process and bundle our own application code. Now for this demo, what I am doing is I am using one of the existing repo from that Srivasan has, and which is time series, and then I will use this particular Spark code. Srivasan, you want to walk through this code quickly, and then
Yeah.
I'll take over.
Yeah, sure, I can do that. And is it in 100% Zoom? Just check it out. Like the browser Zoom, is it 100%, Pradeep?
Yes.
Okay. Okay, that's fine. So I think we are able to see. So a quick note on why we picked the problem, right? Like if you see, basically, you will not encounter a Spark problem in machine learning unless your data grows to a particular volume, or you need a distributed compute processing in some heavy workload. So let me give an example. If you take a typical retail industry, and if I'm doing a time series modeling, right? Typically, if you take retailers like Walmart or retailers like Amazon, they have millions of product. And when you want to predict a demand or forecast a demand of a particular product, basically you have to do at an individual product level. And you may end up having multiple forecasting time series over there, right? So basically, I cannot combine everything and forecast create a single time series to forecast everything. My shirts may have different demand cycle than my pants, and then my sweaters, right? Typically, if you really see off late, with the coronavirus, the shirts sell more than the pants. The reason is half of the people on a Zoom call, pant does not matter, right? That is one scenario. The second thing is, now we are entering the winter cycle, right? Sweaters might sell more, but during summer the sweaters might sell less. So typically you are entering into a mode where you need to run million of time series at the same time. And if you're running it on a single cluster, typically what happens is your data volume across each time series might not be huge, but you are literally like serializing the task. You are running one time series for one product, the second time series for second product. Even if you take a single product shirt, now shirt may have different color, blue, white, and pink, and you don't want to stock everything together, right? You want to see which goes better. So I want to maybe stock white higher than the blue one, than the pink one, right? So we need to predict at that granular level when you take a retail, or even in the energy sector where we are predicting energy per house load. So that's the reason we picked this problem. This is a multiple time series problem. Typically, there's a retail data set that we are using. If you come down, uh, so the data set for that we are using as basically the store ID, the date, and sales. There are 10 store IDs in this, but in a real world, Walmart has more than like 20,000 or 40,000 stores. I don't know the exact number. It may be even more than that, right? And within that store, you will have a lot of products as well. Here I have shown only at store level, but within each store there will be a million of product or thousands of product, right? So this is what the data set is, and what we are going to do is we are going to use Spark, where each particular we are going to repartition this data in such a way that each store ID by itself will be running as a separate parallel process. Now you can write a multi-threading by yourself in Python, but it's not scalable in a single node yet, because the data set will be used with huge when we are talking about millions of product. So that's why we are going to repartition this data and run it across multiple nodes, right? That's the idea of it. Actually, I have a detailed video on this particular one, and I will put it in the comment of this particular webinar, which you can go and watch. But to give a quick gist, come down, Pradeep. I'm just doing some analysis. The core of the code, come down to the pandas UDF. The core of the code is over. Yeah, on the top, I'm just showing plots on various time series, how it looks like. Go a little higher. Yeah. To the plots. Yeah. So here, if you see, like this is all each and every store ID, how the series is. Yeah, there are like a lot of difference in the series. It's not like exactly same. If you see the bottom one, the peak is different in the third cycle than the top one. The peak is different, right? So we cannot create one single model. Now go to the pandas part. So what we are doing in order to repartition the data, we are using a pandas UDF here. And in the pandas UDF, basically what we are doing here in the pandas UDF is we are creating a profit model within it. Now Spark by default has its ML libraries, right? But the ML libraries, maybe time series, you have a better library outside, or if you are running an deep learning, maybe you want to use PyTorch or TensorFlow, right? So how can we bundle this together? Now, when I run only Spark ML job, it's easy for me to just run Spark ML. There's no dependencies involved. In order to show the dependency, we are using profit model within Spark. And in the profit model, what we are basically doing is we are creating a pandas UDF, and we have created a function over here which will group the data for us. Here I'm telling like pandas UDF dot group map, so it will work on a group of data, and I will tell you how I'm grouping the data and doing repartitioning. But before that, in this I'm taking the data, I'm creating a profit model for time series, and then I'm calling the model.fit function to model this, and then I'm creating a future data frame. Future data frame is basically the forecast data frame. Now I have my model created, how much time in the future I want to really forecast. And here I'm telling I want to forecast for 5 periods, and my frequency is week. My data set is in the week level, so I want to forecast for to a week. And then I'm calling the predict again on the future data frame. And finally, what is there? I have a output created with the timestamp, the kind of vector that is y-at is basically the prediction or forecasting value, and each forecasting will have an error component, that is the upper prediction value and the lower prediction value, or the upper confidence interval or the lower confidence interval. And this interval is given in the top in the profit model, where I'm telling interval width is equal to 0.95, right? That is a 95% confidence interval. And finally, I am joining this with the store ID and everything to tell for each store what will be the future prediction. Now I have 10 stores. Can run seriously. That's where the next function comes into play, where I am telling result equal to store part, right? The store part is nothing but the data frame that we have. I am grouping by store ID. So each store ID, I will kind of act like a repartition over here. And then I'm applying the function that I created on the top called forecast sales, right? And then I'm just adding a column training date in my final output, telling like when this particular forecast was created, right? So basically the main thing is the bottom part, which will group by each store ID. And you may have like store ID, comma product ID, comma product category or something like that, right? You can have any amount of group by. So what it happens, like if I have millions, each of this will be created, and different executors will act on it. It's like kind of repartitioning into multiple executors of Spark. And that's what literally this does. So now the major challenge is, I have this, I can model this with bundling all my dependencies. You saw what Pradeep showed you, like you created a base Spark image. Now we have to bundle our dependencies and our code with this code with the data frame. Now we are going to use Amazon S3 to read the data and store the data back. Here I am using just a local data set. So all these things we are going to take this, run it in a cluster, and then spin it up and get the output. And we are parallelizing as well. And it's pretty much applicable wherever you are dealing with either huge data set where you are dealing with dependency. Now, if you are having this dependency in a multi-tenant cluster, think how it will be. Like you have multiple teams coming. One may need Facebook X version and other may need Facebook Y version. So you have to start creating individual Conda environment and give it. But with Spark on Kubernetes, you can just bundle a single container, run it, and then finally in deployment, hand it over to your software engineer where they can just use that specific part of the container image and then just bundle it and call the predict function. So that's it about this part. Go ahead, Pradeep. You can continue on how to bundle it and take it forward.
Thanks, Rivasan. So as Rivasan explained, right, we have written this code, and which is a very interesting problem, because we are looking at kind of time series forecasting, and we're predicting what will be the sales, and then we have a bunch of dependencies. I think that is where the complexity comes in, and we are talking about how to work with that. So I have taken that code, and then I have the Spark code as an Python function, Python file. And then what I have changed here is, as Rivasan mentioned, we have we have put this data set on S3. That is what our source is, and we have created all that Spark code that you saw. That is in this Spark ts.py. Now, the next question is, how do we bundle this? How do we create a Docker image out of it? So we have this base Docker image, which is nothing but the Spark, the native Spark binaries and dependencies. And now we have a Python code where we are trying to do an ML prediction. And then we need a bunch of more dependencies along with the Spark binaries and then package it together. So that is now where we create a Docker file. So let me walk you through that. So in the Docker file, the way it starts is we always start with a base image. So since this is Spark PySpark code that we are running, I'm taking the base image that I had created as a starting point. So I'm taking that, and with that, I'm getting all the Spark binaries already bundled. Now I have to put or add the dependencies that are specifically to what I need. So that is where I add all the dependencies here. And as we were saying, right, this particular code works with a specific version of PyArrow, which is 0.14.1. So you can see how easily we can just mention that version here and not worry about what is running in the cluster, how to override it. Can we have two different versions, and then how to use links and all of that? We don't have to worry about. We are creating a container with all the dependencies, Spark plus external, and then we are also specifying specific versions that we need for this particular code to work. So these the run lines that you see, I'll just highlight it here, are all the dependencies, the additional dependencies I need for this code to run. Now, once that is done, I am creating a directory, which is jobs, and then the Python file, which is my PySpark code, I am putting in there because that is where I will refer inside the container. So this is in the container. When the image, the container is spent, starts running, I can always find my Python code in opt jobs directory. So this is the Docker file that we will use to create this image. So next, to create an image, I am using Docker, and command for that is docker build, and then I am tagging this as Kubernetes Spark, and I'm saying that all the required files in my current directory. So when I do this, it is basically it runs through the entire Docker, Docker file that we went through. So it goes and it installs all the different dependencies. Then it moves the files that we copied, and then it creates the final image with the name of Kubernetes time series Spark, and the version is latest. So if you see in Docker images, we had these three base images using the Spark PySpark, right? The Spark Pi image. Now I have created this particular um, image, which is derived. It's bundled and packaged along with all the dependencies. That is how you will see the size difference between the base image, which is around 1 GB, to this particular application image, which is around 2 GB. So once I have this particular image, the next thing I need to do is, because I'm using AWS and EKS, I need to push it to the ECR. I will not be doing that here because it uses account numbers and stuff like that, which I will not be able to show here. But later on, we are going to put all these commands in the comment, and so that you can all refer to it. But I will still show that. So once I build this, the command so the first thing I will have to do is I will have to tag it um, to a specific repository, right? This xxx is your will be your account numbers and whatever name of you have for the repository. So that is what it is. So you will have to tag it with the right repository name. And as you see, this is ECR, and I am using USH2. And then I'm taking this Kubernetes Spark and the latest version, and then I'm trying to tag it. And once that is done, what you can do is you will have to push it to ECR. So basically, what this does is it actually pushes this image from my local to ECR. I'm not executing this step because, as I was showing you earlier, I already have done that, and I have pushed an latest image to ECR. All right. So now at this point, what we have is we have our EKS cluster. The first thing that we have set up, we had created the rbac roles and policies. Then we created the ECR, the container, and then we created our Spark, the base image. Then we have our application and then ML code using PySpark that we want to use, and then we bundled it and create an application specific image, and then we pushed it to ECR as well. So from building perspective, we have created everything that is needed. Now the next thing is to execute and run that container. So for doing that, how I will be running that is I am creating another Spark job. Let me quickly open this file. This particular file will actually have the Spark basically run the job and then submit the job to the cluster. So once that is done, the next step would be to submit this particular job. So let me quickly do that. So now if I say cube, now I'm interacting with my EKS cluster. If I say kubectl get, let's see first jobs, I can see that the Spark on EKS job was created, and the age is 13 seconds. Now let me do kubectl get pods. So what you can see is this job triggered the driver, and the driver has already, I had created like two executors. So both the executors are created and it's running. So let me quickly do that once again. Now executor 1 is running, executor 2 is pending, and my driver is still running. And then if I have to see the logs of what my driver is doing, I can do that with kubectl logs and then this driver. And then I can see where it is and which part is running. So I think it's still processing the completed this task. It's working on the next task. Let's see the status. Okay, and it's completed now. And how it works is this is completed and it's been like 89 seconds, and I submitted the job first, and that is 92 seconds. So how it works is, if you remember, when I submit the job, the driver is kicked off and the driver kicks off the executors. But once the executors are completed and they are done, then the executors are deleted. Only the driver pods are left, and this is because you want to see the logs of the driver. So if I say kubectl logs and then this particular driver, now you can say that it is shutting down because it has reached the end of code. It printed everything that I was looking for. And then if I go to S3, see if my file was created. Yeah, it got created right now. So this is the forecast results that we were talking about, and then this output got created that I can use it for my further analysis or for however I want to use it to take actions on them. So basically this is the entire process of how you run a Spark on Kubernetes. And then in today's demo we have used the EKS cluster. We started with setting up the EKS cluster, then the ECR, then we went with creating the Spark base image, then creating the application code, then the application image, and then submitting the job on the cluster. So I think that's all I have from the demo perspective. Srivasan, that's all from the demo perspective that I have, and I'm
Yeah.
done with that.
Thank you, Pradeep, very much. While before we go to the questions, right, maybe I want to add few other points over here, right, like how this helps in the real world. So if you take really today, we always think about big data on-premise as multi-tenancy. And with Spark and ML workload, we have seen actually multi-tenancy does not work, not only because of the dependency, it because of the resources, right? Like most of the cluster is occupied, and machine learning jobs requires resources at a particular point in time and requires most of the resources. And once the job training is complete, you may literally have the cluster completely like idle, right? So if you in on-premise or on cloud, if you have like a cluster that is like either OpenShift based in on-premise or your own Kubernetes cluster or on the cloud, any cloud, be it AWS, GCP, or Azure, which all supports Kubernetes have their own Kubernetes engine. So this is very good to keep the cost low as well as have dedicated resources. So basically, what you're doing here, like the step that Pradeep showed from the beginning, even though it looks like pretty complicated steps and process, you can all bundle it into a single CI/CD pipeline. So basically, as soon as you want to train, you can have a CI/CD pipeline that can spin up an ECS cluster for you. EKS cluster for you. It can then create all the images for you. All the images can be pre-created and pushed in your local repository or into the base image is going to be common across the projects. So you can create it and have it in AWS container registry, and then based on your application, you can go ahead and add the dependencies and then bundle it together and then completely run it on cloud. And once you are done, you have the results. You can match the results. If you want to do some modification, you can do modification, run it again. So you are just paying for AWS resources that you are actually using. You don't have to have the cluster be running all the time. And at the same time, you get dedicated cluster when you need it. Right. So that's one thing I wanted to make. There are a couple of questions, Pradeep. The first question is basically about, do we have any options to look at logs similar to Yarn? Also, does the job use dynamic allocation?
Yes. So Yarn, if we are looking at when we are saying Yarn, we have an option to look at Kubernetes logs, and then on the Kubernetes cluster itself, we can create Kubernetes dashboard, and that dashboard will give you all the logs of the of the other kubelets and the other services that are running on that cluster. So the cluster monitoring can itself be done, and then the for Spark jobs, we can always look at the specific driver logs or the job logs. And the second question, Srivasan, can you say repeat that once, please?
Can the job use dynamic allocation?
Yes, that while this job is using dynamic allocation, like we can have what is the multiple number of nodes, and how much, how many max number of pods can be on each node. It That is how it does when we ask Kubernetes to just spin up and use, let's say, spin up, let's say, one driver and 5 executors for a job. But then what we can also do in the job, we can have specific affinity as well towards a specific node. Say, for example, I have a workload that I want to run it on a specific node. I can always bind it to that particular node itself. But if we don't do that, then it will be the best utilization of the cluster.
Yeah. Thank you, Pradeep. Like, the next question is basically, the can we use any other container technology like container RD or basically RKT apart from Docker? This is an interesting question because I have not tried anything apart from Docker. So can we use it?
I think uh, we can. I haven't tried that, but we can see the containers are anyways. There are containers that are running right now with Kubernetes. So even in Yarn, if you look at Yarn, that is also containers that runs when you submit a job. But then the problem is we are talking about specifically Dockers and Kubernetes is because how Kubernetes manages the cluster, and then how the advantage we get in dockerizing it. But if we can check on Spark if there is affinity for other containers, but I am not sure if they are supporting at this point of time. We'll have to explore that.
Okay. The next question is basically, just know that we got is, when calling from S3 to Spark without any pre-processing to Spark RDD data store, will the pull work for parallel processing?
So that's a good question. So the how it works is that it depends upon what you are using. If we are using the Spark and then Spark through S3, then it does creates it does use the bandwidth and then creates the parallel processing, as I understand.
Okay, so Bala, like maybe you want to iterate on the next question. It says like, please could you answer from data quality angle, right? So I will also answer your previous question on parallel processing. So typically the parallel processing can be multiple way, right? We can create our own splits and give a directory of S3 for processing. The second thing is you do it in the Spark job. So maybe you are reading in a single place, but you can repartition immediately. You can either have pre-partitioned or you can repartition it. That is one thing, right? Second is basically answer from data quality angle that question. Maybe if you can elaborate. If it's only data quality, yes, then you can do all the pre-processing stuff in your Spark job. But I'll wait for you to elaborate that particular question, as I did not get the details of it. Right. While we have other question,
Yeah,
Pradeep,
and
what Spark operator?
can you repeat that, Srivasan? Sorry, I missed that.
What is the Spark operator, right? Basically, Kubernetes, Spark Kubernetes operator is an operator, just like the way you bundle and make your application accessible to Spark. I think that maybe that was the question. I just got what is Spark operator. So you have multiple operators for Spark. You have GCP provided Spark operator. You have custom operator that comes bundled along with Spark, but only disadvantage is you need to add all the dependencies based on your cloud, like Pradeep did over here, where he added all the AWS client SDKs and everything, right? So you are customizing the default operator of Spark. Now you have also GCP operator where it comes predefined for GCP. So maybe just a question on what is Spark operator, that was. Maybe I answered it. Sorry to
Okay.
snap from you, Pradeep.
No, no, that's fine. And also, Srivasan, what I was telling about the data quality, right? So there are frameworks on Spark, irrespective of how it is run, to do the data quality. So there is nothing different in terms of processing and how we will program our PySpark codes. So if we were, writing our PySpark codes in a specific best practices that don't get changed when running it on Kubernetes, the execution, the bundling, that is how what we are talking about. But there's no difference in terms of how we write our jobs in terms of for even data quality or to do anything else around that.
Right, right. And I think, Bala, I hope that answered your question. If not, like maybe you can post another question to get it answered. I have next question, which is like pretty interesting. So when you are not using the Elastic Managed Service and we have our own cluster hosted on any cloud provider, how to configure the Spark master and worker like they would always be alive?
So you we are not setting the Spark master. So what we do is when we do a Spark submit, where we have to give our Kubernetes cluster DNS. So what Spark allows is in the Spark submit, it lets you, and I'll put a command later on as well at the end of the video. So what we have to do is we have to give the master of the Kubernetes DNS. That is where because even if your Kubernetes cluster is let's say serverless, or it's the control plane will always be running in the master, the DNS will always be there. So that is what the Spark needs in order to spin up the jobs. It doesn't need like anything else, like the host names or IPs or anything. We just need to give the Kubernetes DNS.
Okay. The next question is like, what is the best way of creating Spark cluster in Kubernetes for production? Maybe you can start with it, Pradeep, and I also have something to add on it. That's an interesting question. Yeah.
So Spark cluster. So here, here what we are. I'm trying to understand this question, Sivas, and I think it's more around how do we ship this to production, right? Is that what it is?
So based on the question, it is like, what is the best way to create a Spark cluster in Kubernetes? And maybe I can start with it, right? Uh, Basically, yeah, we do not create a cluster. We leave it to the more like a CI/CD pipeline on demand based on the job.
Right.
Because if you want to have a cluster in specific, think it's similar to EMR, right? We start the job, we just end it. You can keep it running, but it's like a resources that we don't want to waste. So that's what I would think is the best way to go to production. If you want always running cluster, then basically you can use any other service like multi tenancy. But here it's going to be more like job specific. And am I right, Pradeep, in saying that, or you can add more to it?
No, that's the right thing. Like if you look at the environment that I was showing, I was specifically having those two dedicated nodes. But otherwise, if I was running this in production, I would have used the auto scaling option in which the nodes get spin up when based on the requirement and the need, right? Rather than having a cluster always like the worker nodes always up and running. And then it's a cluster that we can use for running our ML jobs, Spark jobs, all of that. And the Spark binaries itself comes packaged in the Docker image. So that abstracts the containers, dependencies, and all of that. So yeah, that's just to add. But you said it right, Srivasan.
Yeah. So the next one is basically, can you elaborate how the Spark RBAC was tied to the job?
Right. So what happens is the Spark job, when I submitted a job, the job basically um, kicks off another pod, and then the pod is basically how, if you look at how Spark works, you trigger off the we trigger off the driver first, and the driver actually then spins off the executors processes, right? So what happens in Kubernetes is that when those executors are being triggered, then the Kubernetes should looks at the permission in terms of does this particular job has access, and what is the service role it needs to spin up those executors. So that is where that RBAC role comes in, and that RBAC role basically tells the Kubernetes clusters that the driver can spin up another executor, another pod, which is executor here, and we use two executors here. So it's going to spin that up, and then it's using that RBAC policy in order to use it, and that gives it the ability to actually spin up the worker and the executor nodes.
Yeah. Uh, I think this is the final question, and until we get anything. It says like, uh, this is a repeat of like previous question that Bhojani Ali had, right? It's basically, we have our own cluster, how to configure Spark master and worker that they are alive. The question is basically, but for the orchestration of the resources, the Spark Kubernetes master will do that. You see, it's a question we is asking whether the orchestration of the resources will be done by Kubernetes master or not.
Yes, so Kubernetes master will know like what is the how many workers it had, and then if it can scale or not, depending upon which where you are using, right? So let's say I am having a cluster which is running. It is a fixed rigid cluster. Let's say with 5 worker nodes, and I already have the max capacity running. So what happens is now if I trigger the next job in Kubernetes, and if it cannot increase the boundaries of the cluster, then it that's where Kubernetes orchestrates and knows that, hey, it say for example I requested 15 GB of memory, right? It says that I don't have that much, and it puts that service on wait, right? So that pod, you will see that pending state, and then when some of the jobs are completed and that memory is freed up, then it will launch it. So that orchestration will be done by Kubernetes itself, and it will look at what is the available resources on the cluster, what is the ask, and then if it can spin that up and then start that particular process. So that's managed by Kubernetes.
Got it. And thank you, Pradeep, for taking time and answering it. Actually, like one thing I felt, it's this is a difficult subject to cover on a live session. The reason is there are too many moving parts, even though some were pre-built because of the time constraint, because sometimes like, the initial part takes off a lot of time. Even then orchestrating and running it in a real demo and in a real live show, really the demo fails, and debugging these kind of scenarios are pretty hard. And thank you for really putting a live example rather than, if you see, if you go to the default demo, it's SparkPy. SparkPy anybody can run, but giving a live example with all the dependency management and everything, which are hard to find and get and really like show it to the users, right? Maybe if you can put all this in the Git code and I can share it and to get
Sure.
it for everyone. Thank you everyone for watching. Thank you very much. Again, meet you till the next live webinar we will have. Thank you.
Thank you, Srivasan. Thank you, everyone.